And I've got all of this from hobbytronics.co.uk, and there are plenty of suppliers in the US that you can get this from if you just Google TMP 102. There is a diagram of how to connect up your breadboard, which is made available in the document pack. See the description field of this video. We'll be able to take the readings from the chip and output them to a website and graph them, which look very attractive, and we're able to plot that over a length of time. And there's a picture of what the final breadboard should look like once it's been completed. It's quite a simple diagram. So you have the top side of the chip and the bottom side of the chip. You can see on that top side there, I've just circled the actual temperature sensing chip itself. We need to make sure that it's facing up. So when you connect up and you solder the pins into the actual chip, you need to make sure that the actual temperature sensing chip is facing upwards and is located at the top, and the long pins are at the bottom, which is with the markings. So when you actually plug it into your breadboard, the temperature sensor is actually facing up into the air and not down onto the breadboard. So you need a soldering iron and possibly one of those handy hand things just to make your life a little bit easier when soldering. Okay, so you have two different scripts that will be run. The first one is tmp102.sh, which when run will actually just output a simple temperature to the screen. And what it does is it talks to the I2C bus, that is what the chip talks on, and will take the temperature reading and read that back, which is in a hexadecimal format, and it will then translate that into a format that we can actually read in a normal decimal format. The second script is update.sh. What that does is it will run the first script we just mentioned, the TMP102 script. It will then take that reading and it will send that to a file called blank.json, which will then generate send.json, which we'll see in a moment, and we'll see the content of the actual reading in that. That send.json will be transmitted via a HTTP put request using this curl command here, and will then be uploaded to this website here, api.cosm, and it will be connected and authenticated basically by this API string we have here, which will make our request upload unique to our temperature reading. That's what the blank JSON, which is essentially just a template, and once the script's been run, it will produce this file called JSON, which will read this unique value of the temperature sensor right now, and that is what will be uploaded to the website. Okay, so once you've got your breadboard connected, you need to go to the document pack in the video description here and find a file called command.txt. In there you'll find a list of the instructions you're going to need for this example. So first thing we need to do is to update the apt-get repository. So run sudo apt-get update. That will ensure that when we download tools, we've got the most up-to-date version. The next thing we're going to do is run the command sudo apt-get install i2c-tools. There's the command. What that's going to do is download the I2 bus interpreter, which will allow us to actually read from the chip. Then once that's done, what we're going to need to do is modify one of the system files. So you need to run the command sudo nano to edit, and then we're going to edit /etc/modules. And what we need to do is to add two entries to that. And you can see on that command file there, the two entries, we just add them to that file. And then once this is done, we're then going to need to reboot the Pi. So run the command sudo reboot. And that will reboot our Pi. So I'm just going to click restart. I edited that quickly there. So we log back into the Pi. And make sure which path we're in. Okay, so we now need to add a user. When you copy and paste that, you might get the dots instead of dashes, so make sure you change that. And we make that change. And we're going to need to log out of the Pi and re-log back in again. I've just skipped that quickly. Okay, so what we're actually going to do now is run the I2C get command, which will actually read from the actual temperature chip. What it will return is a hexadecimal format, which is something that we can't read easily, but we can actually see that it is actually getting a successful response back from the external chip. Okay, so we now run that command and we can see that it returns a hexadecimal value, which means it's actually reading from the chip successfully, but it's not something that we can easily understand. So we need to get a copy of those scripts. So make a directory for them to go into, mk dir, and then the temp 102 directory. Change into that directory, and make sure you're in /home/pi/tmp102. Okay, you now need to run the command wget and the path of the package file. So run that command. You should find that in the command.txt document, and then run the command tar-zxvf and then the file name, which will extract all of those files to your Pi. So now we've downloaded those files onto our Pi, we want to run that script. So run the command ./tmp102.sh, and then we can then see how it actually returns a temperature from the chip that we can actually understand. Okay, so open up a browser and go to the cosm.com website, sign up for an account, and once you've done that, log in. You can see here the temperature sensor graph I've set up earlier. So what we're going to do is I'm going to remove all this data and show you how to set up your own and how you can actually take the temperature readings from the chip and then upload them to this site and graph your readings nicely. Okay, so we need to set up a new feed. So the first thing you need to do is click on the new feed button, and then we want the something else we're going to be setting it up as. So we're going to say no, we're going to push our data to COSM. We're going to give it a name. I'm just call this my living room temp, and you can say next to the next two options and then create. It's going to give us a feed ID. So what you want to do is to copy that. Have a quick look at the command.txt file for reference, and what that will show us is that you need to enter this into the xxx field on update.sh. So we use sudo nano update.sh, so we can actually edit that file and then search for where we have xxx in the this particular script, and replace it with the unique field ID they've given us for this feed we've just created. Okay, save that. Okay, back to our website, and we're going to finish creating that. Next thing you need to do is to set up a data feed. Okay, give it a name. I'm just going to call it temperature. That's our data stream ID, and copy that and make sure we save that data stream. Okay, go back to our text file, and we're going to edit the blank.json file. So sudo nano blank.json, and we're going to find where it says YYY, and that's going to be our data stream ID, which we're going to call temperature. Okay, and again, save that file, and we're going to do the last one that's there. So what we need to do here is set up a API key, so we can actually authenticate to the site. So we go to keys, we then click the X button for new, we then give it a name, this doesn't really matter. We then want to select all for all access privileges, and then create, and then it's going to give us our API key. So copy that information, go back to the file, we're going to see we're going to update the update.sh file, and we're looking for the zzzzz parameter, so sudo nano update.sh, find where it says zzz, replace that, there we go, and save that. And then what we'll find, if you now run the command /update.sh, it will run those scripts, and it should send an entry, a reading to the COSM website. Okay, we're just quickly going to click on that logo, which will refresh the page, and we can see now there's in the corner there is all of a sudden a line, which means it's taken a reading. So we just quickly run that again, and we refresh the page, And what we're going to do is need to filter this on the time period we're looking at, which is just say 5 minutes. And what we can see is there's been 1, 2 readings at that point in time. So there we go, there you have it. So it's all well and good being able to send information to this website by running the script, but what we actually really want to do is to be able to do this on a regular basis. So we want to be able to schedule how regularly we take these readings and how regularly we send that information to the website. So what we're going to use is essentially a service called Cron. Cron is a scheduler, and it runs under almost all Unix or Linux based systems. Okay, so to schedule this job, we need to edit the cron file. We can do that by running cron tab space -e. And then what you're going to want to do is take the example script we've got there. So we're going to copy that syntax and then paste that into the bottom of the cron file. This will run every single minute on the minute, and will upload that information to that website. If you want to know more information about crons and scheduling, drop me a comment field and I'll try and make a video on it. Okay, save that file, and if you run cron tab -l, you'll see that that's been saved to the cron service. Okay, so what we need to do now is, if we quickly run the command date, it will tell us the exact date and time on the Pi at the moment, and will allow us to see when the script is going to run. So you see there I'm just a few seconds off, and I run again, and we go past the minute, and that would have run. Okay, so I left this to run for a few minutes, and there's the result. You can see as it plots over time, and the longer you leave it, obviously the longer it gets. I think there's a 3-month limit to it or something, but there you go. You've plotted your temperature from an external sensor. If you have any questions, please